Hello guys, welcome to BYJU'S Exam Prep, the most comprehensive preparation app for all the competitive exams. So today I am going to discuss interrupts and direct memory access. So DMA and interrupts in computer organization and architecture. So in this monsoon series of GATE 2024. Please let me know, is my audio video everything is clear? And you can join quickly and do subscribe the channel and share with your friends. Am I audible and visible? And I hope you have been attending my classes for the last 1 week. I've been taking in this monsoon rankers 2024 in the actually computer organization and computer architecture. Okay, so I will be starting theory of computation also in the month of August for this monsoon series. So all of you please keep watching the classes regularly, and if you have not yet done the subscription, please do subscribe the channel right now, and you can share with your friends, as we are providing a lot of free content to you. Like apart from the technical sessions, we are conducting the general sessions, guidance sessions, preparation strategies, tricks and tips, and also we are providing coffee with concepts and different types of things we are providing. So please try to make use of this. Okay, and please share with your friends, and also do like the session if you are really liking it. And I hope I am audible and visible to all of you. Am I audible? Can you confirm me once, some of you please? Okay, fine. Now let me start the session. Yeah, before I begin the session, let me introduce myself. Murali Krishna Bokkasamudram. I am having 21 plus years of teaching experience, both in the GATE and also I worked in different engineering colleges. And these are some of my credentials. You can just have a look. And these are the subjects I taught, and my area of expertise: theory of computation, operating systems, computer organization and architecture. That's what I am teaching you right now. And computer networks, digital logic and ICT, information and communication technology. Okay, shall I start the session? Yes. Hi Sandy, good evening. I hope every one of you are doing good, and every one of you are attending all the classes right from the beginning. If not attended, please go through the videos. These are available. YouTube links are available here in the Telegram group, which I will share you in the comment box after the class is finished. Okay. So now let us start the session. Before that, you can just have a look at some of the offers we are providing here. If you wanted to take a step towards success in the GATE exam, what you have to do is immediately you can go for registering for this national level scholarship test for the GATE exam. It is on 30th July, that is coming Sunday, from 9 AM to 9 PM, the different sessions. And you can get up to 90% concession on our programs based on your score in the examination. Okay. So try to make use of this offer and try to register right now. After the class is finished, you can register. And you can also share this information with your friends, those who are preparing for GATE and engineering services. Okay. Now let us, there is one more workshop, that is regarding the master plan to conquer the GATE 2024 in just 6 months by expert faculty Abhinav Negi sir. And this is a free and live interactive workshop. It is on 1st August at 7:30 PM. Okay. And I hope every one of you will register for it and try to get full advantage of this. Okay. Now let us start the session. This is the first question. So actually most of the questions are related to comparing the interrupt service and then DMA. So both the things are meant for data transfer. Okay, from IO devices to memory, and also from memory to IO devices. Okay. So DMA is most efficient kind of transfer technique, and programmed IO is there, interrupt initiated IO and DMA. So in our syllabus we are having interrupts and DMA. So you can just have a look at this question. On a non-pipelined sequential processor, a program segment which is a part of interrupt service routine is given to transfer 500 bytes from IO device to memory. Okay, and to transfer that 500 bytes, this is the interrupt service routine. If I go with interrupt service program, and for we have to execute this program. Okay, and assume that each statement in this program is equivalent to a machine instruction, which takes 1 clock cycle to execute if it is a non or load store instruction. The load store instruction takes 2 clock cycle. That means So initializing the address register takes only one cycle, and initializing count value to 500 takes one cycle. Load instruction and store instruction takes 2 cycles each. This is also 2 cycles storing. Incrementing the address register one cycle, and this decrementing the count and loop also one cycle. So this loop is repeated for how many times, that depends. So actually there are 2 instructions. They are executed only one time. Okay, initializing the address register and then initializing the count, only one cycle. But once if it is began, loading a byte from a device, 2 cycles, and that byte you have to store in memory in the address indicated by address register. Okay, and then increment the address register for the next byte to load in the next address, and decrementing the count after you are supposed to load 500 bytes now. So after 1 byte is loaded, count is incremented, means remaining 499 bytes to load. And after decrementing, if count not equal to 0, go to loop. If count equal to 0 means all 500 bytes will be finished. So this is repeatedly executed, this loop, for 500 times. So that means if you are going with interrupt initiated execution, so the same question, interrupt initiated execution, how much time it takes? So 1, 2, and here there are 2 cycles, as I told you now. So total 2 cycles plus 500 into 2 plus 2 plus 1 plus 1 plus 1. It is a 4, 5, 6, 7. 500 into 7. So 3502. 3502 is the total number of cycles taken for execution of or the transfer of this data using the interrupt initiated IO. So 3502. Okay, now this is the total figure. Now assume that each statement in this program that according to the given data we have considered, and the designer of the system also has an alternate approach of using DMA controller to implement the same transfer. That means for the transfer of 500 bytes, alternative method is DMA, which is faster actually. So which requires 20 clock cycles for initialization and other overheads. So DMA actually we need to initialize. So for initialization and also at the time of finishing also some cycles required. So it is taking start and stop, it is 20 cycles, and for every byte it is taking 2 cycles, and each DMA transfer cycle takes 2 clock cycles to transfer 1 byte of data. So as far as the DMA is concerned, so interrupt initiated IO, how much time it is taken in the form of number of cycles. So in the form of interrupts, it is taking 3502 cycles are taken. In the case of DMA, it is clearly mentioned, okay, for initialization and other overhead 20 cycles, and for every byte we transferred 500 bytes, it is taking 2 cycles. So it is a total 1020 cycles. Okay, now then what is the speed up? They are asking what is the approximate speed up when the DMA controller based design is used in place of the interrupt driven program based input output. Can you anybody answer here? So the speed up, actually definitely DMA is faster. How faster the DMA is when compared to the interrupts? So that is what the speed up is. So the speed up factor is equal to 3502 divided by 1020. So exactly you will get 3.4. 3.4, option A is the right option. I hope for everybody it is clear. If not, please do let me know. I will explain, and you can share the class information with your friends, and also do like this session if you are really liking it. And I think yes. Am I audible? Please confirm me once. You are able to post. Just confirm me once. Are you able to post the questions here? Okay, now let us move on to the next question. Question number 2. The size of the data count register of a DMA controller is 16 bits. Okay? Yes. And the processor needs to transfer a file of 29,154 kilobytes from disk to main memory. The memory is a byte addressable, and the minimum number of times the DMA controller needs to get the control of the system bus. The control of the system bus from the processor to transfer the file from disk to main memory is how many times we need to request. So once if DMA has requested, how many bytes of data we can transfer, that is decided by the data count register. So DCR is nothing but data count register. Okay, what is the data count register size here? 16 bits. So using 16 bits, one time if we request, we can transfer maximum 2 power 16 bytes. 2 power 16 bytes of data we can transfer if the data count register size is 16. So initially I will tell you an example. Let us suppose the data count register value 100 for example. So for every transfer of 1 byte, the count will be decremented. So it will become 99, next it is 98, and it will go up to 1, again 0. So when it comes to 0 data count register, all the 100 bytes are got transferred. Okay, na? So that is the criteria. Now coming to this. So 29,000, what is the file size? The file size is equal to 29,154 kilobytes. 29,154 kilobytes. And if you request for one time, 2 power 16 bytes is nothing but in the form of kilobytes, 256 kilobytes. Like that, how many 256 kilobytes reaches to 29,154? Still file is not finished. For example, one time it is requested, 256 kilobytes are transferred. Again data count register, again put 16 bits, and again we have to request one more time. Like that, keep on requesting till the file is transferred, bigger file. So if you divide this file size, so 29,154 KB divided by 256 KB, and kilobytes cancel, you can just find out 29,154 divided by 256. What is the value of this? Can anybody tell me? 29,154, just wait, 29,154 divided by and 256. 29,154 KB, right? Yes, exactly. So 29,154 divided by 256. Why 256? Actually 16, very sorry, it is not 256K. There is a small mistake. It is 2 power 18 means 256. Actually it is a 2 power 64K only. Small mistake is there here. So maximum 2 power 16 by 2 power 16 is correct, but the value of 2 power 16 is 64 KB. 2 power 6 is 64 only. So just you can change it. Yeah, by mistake. I thought it is this thing. Okay, now 64 you can take. Sorry for it. And 64 KB, here it is a 64. And what is the value of this? 29,154. None of you have answered. Just a moment. So 29,154 divided by 64. So 455 point something has come now. But 0.5 times we don't request now. Even if you requested for 455 times, 0.53 has come in, still some data is there, and one more time you have to request. Even if 455.1 also, we have to round it to 456, because even after requesting 455 times, still some file is remaining. So we have to request one more time for remaining file to transfer. So we can request for 456 times. 456 is the right numerical answer for this question. I hope everybody understood clearly, and if you have any doubt, please let me know. Yes, exactly, Pradeep Dumpala, you are right. I think every one of you have understood clearly. Now shall I go for the next problem? Are you okay? Are you ready? Yes, response is nice. Yes. Yes, tell me. High flyers, you can tell me what's your question. Now coming to the next question. So this is the data related to the question number. Actually, this is question number 3. Data related to the question number 3. A computer handles several interrupt sources, of which the following are relevant for this question. Yeah, I didn't get you, high flyers. Can you, okay. So now coming to these are the points. So interrupts from the CPU temperature sensor rises an interrupt if CPU temperature is too high. Okay, and the second one is interrupt from the mouse. It erases interrupt if a mouse is moved or button is pressed. And the third one, interrupt from keyboard. It rises an interrupt when a key is pressed or released. Okay, and interrupt from hard disk. It rises an interrupt when a disk read is completed. So these are the four types of interrupts. So these type of interrupts are being given for this. Okay, and please let me know what is the answer for this. Now this is the actual question. Which of the following interrupts will be handled at the highest priority? So please let me know. I am giving you some time for you. So please let me know. Yeah. I hope every one of you are responding. Yes, please respond quickly. Which interrupt will be considered as highest priority? Question 1 is which one of the interrupts will be handled at the highest priority? Interrupt from hard disk, interrupt from mouse, interrupt from keyboard, interrupt from CPU temperature sensor. And when they are raised, that is also given. No. That is not correct. High flyers. Yeah, question is like this. A computer handles several interrupt sources of which following are relevant for this question. So interrupt from CPU temperature sensor actually, when the TP temperature is high, automatically to switch off the system and this interrupt is raised. And interrupt from mouse, when the mouse is moved or button is pressed, it will be rising. Interrupt from keyboard, it rises an interrupt when a key is pressed or released. And interrupt from hard disk, when rises an interrupt when a disk read is completed. So these are the things. Yeah, description is this. So usually highest priority interrupt is interrupt from CPU temperature sensor because it is related to the safety of hardware. If automatically when the CPU temperature is high, if the system is not automatically switched off, okay, then it leads to problem, it leads to loss. Okay, so it should be handled with highest priority. Okay, remaining all are can be maskable. Okay, now coming to next one. Okay, I hope yes, very nice. Okay, shall I go for the next? Okay, question number 4. A CPU generally handles an interrupt by executing an interrupt service routine. Option A, as soon as an interrupt is raised. Option B, by checking the interrupt register at the end of a fetch cycle. Option C, by checking the interrupt register after finishing the execution of the current instruction. And option D, by checking the interrupt register at fixed time intervals. So what is the right answer here? I think this also very general question you people can answer. So why the CPU temperature sensor interrupt was very high there? If that is not handled and responded, then it leads to the loss damage to the resource. That's the reason. So this is a different question. So when the interrupt service routine is executed, so usually when the interrupt is occurred, we are supposed to execute interrupt service routine. But when it will be executed, immediately after the interrupt is raised, or after checking interrupt register at end of the fetch cycle, because we are having different phases in the instruction, like fetching the instruction, decoding instruction, and fetching the operand, and then execution of instruction like that. Okay, and the option C, by checking the interrupt register after finishing the execution of the current instruction. Option D, by checking the interrupt register at fixed intervals, fixed time intervals. What is right? Yes, exactly. Piyush Singh, you are 100% correct. Okay, by checking the interrupt register after finishing the execution of current instruction. So once if you have started the execution of instruction, okay, you don't interrupt it unless there is a DMA request for a bus. Okay, that instruction will be completely finishing all the phases and it won't continue with the next instruction. Instead, it will switch to the interrupt service program, and whatever the interrupt is occurred, it will check, and that interrupt service program executed and come back to the next instruction. That means after the cycle of every instruction is finished, we are supposed to inspect whether still you have to continue in the instruction cycle to go for a next instruction or interrupt cycle. Interrupt cycle means we have to execute interrupt service routine and then come back to the next instruction. That is the criteria. Hope everybody understood. As soon as interrupt is right, it won't happen, high flyers, because that is finishing the present instruction. It won't stop the present instruction. Okay. Now coming to the fifth question. The correct matching for the following pair is, what's the correct? So there are two lists given. So this is considered as a group 1 and this is considered as a group 2. So group 1 and group 2 we have to match. DMA IO, catch, interrupt IO, condition code register. DMA IO is a direct memory access. So here what is mapped to what? Please answer this. So I am just doing it. A cache memory is what? High speed RAM. Cache memory is a high performance buffer placed between the CPU and main memory. So B is related to 1. And a DMA IO and condition code register is a register, special purpose register available in the arithmetic logic unit to know the status flags like overflow occurrence and also sign flag, zero flag, to take some condition registers, condition decisions. DMA IO, interrupt IO. Actually, printer is DMA IO. So C is related to 3. Okay, DMA IO, the large amount of data from the disk to memory, memory to disk, we transfer through the DMA. Okay, and interrupt initiated IO, printer. Okay, so we can say A2 and then B1, okay, C3, D4. This is the correct match. And if you have any doubt, you could ask me. Okay, na? And if any one of you have not actually subscribed this channel, BYJU'S Exam Prep Gate ESE channel, CSE, please do subscribe it and please share with your friends. Okay. Now let's move on to the next question. Question number 6. The following are some events that occur after a device controller issues an interrupt while process L is under execution. For example, there is a process L we are executing. So process L may containing different instructions like instruction I1, instruction I2, instruction I3 and so on. Some n number of instructions are there, IN. Okay. So randomly some P, Q, R, S, T 5 points are given. You have to arrange these 5 points in a sequence. And what is the occasion here? While you are executing a process L, okay, and some events are occur in that, please which of these following are correct order in which the events have occurred. Okay, can you answer this? Can anybody answer this immediately? Yes. The processor pushes the process status of L onto the control stack. So actually I will tell you what happens when the interrupt is occurred. Okay, I will tell you. For example, interrupt has been raised while you are executing instruction I2, for example. What we have to do is we will finish the present instruction I2. We don't interrupt the present instruction. Instead, we will complete it and we don't continue with the instruction I3. Instead, we have to go for interrupt service routine. Interrupt service routine is also some set of instructions. Okay, like instruction I1, I2, whatever is that depends on the type of instruction. Okay, if there are M instruction in interrupt service routine, so after stopping the next instruction, we jump to ISR and we execute all these instructions. But before that, next instruction address, because when you go to the execution of ISR, program counter is loaded with the address of I1 of ISR, but I3 address program counter value we have to save in the stack. So we have to use the stack, okay, and save the program counter and other information like PSW and all in the stack, and execute the interrupt service program, and take back this PSW and PC. PSW means program status word, to continue from the place where it has stopped. Continuity. So that means what is the sequence here? Can you let me know what is the sequence? Yes, Piyush, you are correct. The first and foremost thing is queue. The processor finishes the execution of the current instruction. So that is the first one. Then after that, I told you know, the next instruction address I3 you have to push into the stack before you are jumping to interrupt service routine. So that is next is P. The processor pushes the process status of L onto the control stack. So that is the second step. And then third step is the processor loads the new PC value based on the interrupt. So new PC value means the address of the interrupt service program. We have to load the program counter with the interrupt service program address. So that is the third step, T. And what is the fourth step? The processor executes the interrupt service routine. Then after finishing, we have to get back the content of the stack. So the processor pops the processor status of L from control stack. This is the fifth step. So that means QP TRS. So option A is the right option. Piyush, you are correct. Okay, now. So shall I go for the next? Yeah, I think this is the final question. And I hope you people have enjoyed the session. And today is the last class for COA for Monsoon Gate Rankers 2024. And I will be starting theory of computation soon. And meanwhile, please watch all those things, whatever are given, the lectures, please go through that. Thank you so much. Thank you, one and all. See you. Bye bye. Good night.